Okay, in today's lesson we're looking at the early periodic table and focusing on these two main chemists, Mendeleev and Neumann, looking at how they contributed to the periodic table forming the way it is today, without particularly looking too much in our modern day periodic table, and also then looking at the perception of the periodic table throughout its development stages and how it is now. So looking at why it was seen as a curious thing to start with, then became more of a tool, and now why it's an important summary. So our first thing, what we're doing, is looking at some of the scientists that have contributed to the development of the periodic table. So we've got a range of scientists, so you should never assume that only because we're looking at Dmitri, Mendeleev and Neumann, that these are the only two that have actually contributed to it. It's a lot of scientists over a wide period of time that have built up these things. So we're going to first look at, you do not need to know this person particularly. It does help. You may be asked about him in the exam, but you'll be given information on him. And this is John Dalton. What he originally did is we had around about, I think it was about 20 elements at this period in time. What he realized is that we can order them in terms of atomic mass, and that's what he did. You can see even at this point we didn't name them all correctly still. So we've got lime, which obviously isn't an element, it's a compound, calcium, but it was in there at the time, so you can see that there's still some mistakes in there. But he was the first one to actually start arranging it within atomic mass, and that's the first steps of actually realizing that we could order these elements in some way. So he was really the founder of the periodic table itself. But like I say, he is not one of our focuses. This next man, John Newlands, went from realizing what Dalton said about the elements being able to be ordered in terms of atomic mass, and actually then created his own periodic table, which is here. Okay, and what he realized is if you ordered them in terms of mass, what he found was every eighth element, so this would be the eighth, the fluorine is the eighth, had similar properties to the first. Okay, so if you go, hydrogen is our first, count on 8, you get back to fluorine. So he said fluorine had similar properties to hydrogen. If you did that again, then chlorine had similar properties to these two again. So he realized that these then could be grouped, and then he called this the law of octaves, or periodicity based on octaves. And realized that you could group them into 8, and they gave a pattern of reactivity. And this is another step in the right direction for producing the periodic table. Unfortunately though, he didn't take into account the fact that there were still elements being discovered at this period of time, and the fact that his law of octaves actually broke down. So after the first 20 elements, after we get to calcium, he starts missing elements. So for example, he goes still to iron, and iron doesn't have similar properties to oxygen and sulfur. Okay, so they don't have similar properties. But because he had started seeing this pattern, he ordered them all like that, regardless of the fact that actually that pattern broke down after probably the first 20 elements. And this was fundamentally because he didn't have all the elements there. One other thing to notice, it's not really something you need to know, but it's something they could add in. They hadn't discovered the noble gases at this point, so that's why he's saying it's octaves, while the 8th element comes down, because we haven't got that 8th group. So there's only 7 groups, and then the 8th goes on. So he hadn't discovered the noble gases at this point. But the flaw was he didn't take into account that there was still elements being discovered, and therefore that forced him to continue this pattern, this layout of the periodic table, even though some of these elements, well, a lot of them after the first 20, didn't actually match the patterns. Okay, so now we're getting to Dmitri Mendeleev. Okay, one of the he's counted as the actual producer of the periodic table, even though there's been things in the past. And he took this idea of ordering in terms of atomic mass. So remember, at this point in time, we didn't actually know about atomic number. We didn't know about what was inside the atom. I think we assumed that was actually the smallest thing. And what he realised is, if we took this idea, I don't think he actually had taken it from Newland, because they were working at a similar time, but if you took this idea of arranging them in atomic mass and also in patterns of reactivity, he didn't just force the elements into where they weren't supposed to be. He realised actually there might be an element missing there. That's why that one. So for example, that's why titanium. Oops, that's why, for example, we're missing here. He didn't just force this one to go here. He said, okay, there's something. Titanium hasn't got similar properties to aluminium. We're missing something there, so I'll leave a gap and move titanium across. And this is what actually caused him to be seen as one of the founders, because what he then was able to do is say, even though we don't know this element that's got an atomic mass between calcium and titanium, so around about between 40 and 47.9, I can predict its properties. So it's going to have similar properties to boron and aluminium. And the fact that when that element was discovered, it had exactly the properties that Dmitry Mendeleev had said, then that gave him some a reputation of actually this is correct, okay, and they started believing. As you can see, he's put his transition metals in a group here because at the same time we still haven't seen the noble gases being discovered. However, it was easily added on just to the end of his periodic table. We call that group 0 now. But the fact that he was able to discover that actually, and take into account that these elements hadn't been discovered and he left spaces for them, he was able to predict the properties of these elements that had not been discovered. And also publish those findings. That meant that his periodic table was taken through, and Newland's wasn't, because of this fact that he tried to force it into place. So you can see how they've contributed. Okay, so now we're going to look at how the perceptions of the periodic table have actually changed over time. So originally, around about the Dalton time, it was seen as quite as a curiosity, the fact that these elements could be ordered in terms of atomic mass. It was quite interesting, but nothing more than that really. We knew we had elements. It's quite an interesting thing to try and order them and see what we're going to get next. But apart from that, it wasn't useful to us. And then when we get down to the Newlands and Mendeleev time, it starts becoming more of a useful tool. Okay, because like Mendeleev, you could predict properties of things, and the fact it was ordered. You might not have availability of potassium, but you know how it's going to react because it's in this periodic table, so it becomes quite a useful tool for scientists to use. By the time we get to the periodic table we use today, which we will be discussing in the next topic, so I don't want to go into it in too much, but it's actually becoming an important summary of the structure of atoms. Okay, so we'll look at that in a bit more detail. You need to realise that as the development of the periodic table went on, it became more and more useful, and then actually we classify it as actually this is what it is, and we can summarise what atoms look like and their properties and things like that. So this shows you how it's developed over time. So yeah, this is quite a relatively short chapter. This is what AQA expects you to do. So you've got parts A and B, and also the extra parts. So the fact that so understanding how Newland and Mendeleev attempted to classify the elements, so atomic mass, grouping, then looking at B, so how it was incomplete and how Mendeleev overcame that, and how he made his periodic table better and superior to Newland's. And then finally, these extra points that actually come at the bottom of your tick list. You need to evaluate the work of Newland, so actually compare and contrast, see what they brought to the table, why it was good, why it was bad. and how this helps. So the points that were taken and added to the modern day periodic table, which like I say, we'll look at a later date, and actually tells you don't need to know anything other than what we've been given. So Newland and Mendeleev, however, they might ask you, and chances are they will ask you about another scientist. There's no point looking at all the other ones. They'll give you the information. It's just taking out the points from that information and comparing it to either Newland or probably more likely Mendeleev's attempts at doing the periodic table. And the last point is this point we looked at the end, explaining why scientists regard the periodic table first as a curiosity, then a useful tool, and then finally as an important summary of the structure of atoms. And that important summary isn't going to come to the next chapter really, when we see how the periodic table is laid out and things like that. But you need to be able to do these. So what I want you to do now is turn to the front of the booklet, tick off the second box, so the first box of each three you should have ticked off in class or left blank if you're unsure. So tick off the second box now, which is looking at how you've done in the homework, if you understand this after the homework. And also you'd have to move down to the bottom, so the bottom right, to actually do this, evaluate the work of Newland's and see if you actually understand that. What we need to do now is move on to the exam questions as well, the next few pages, and have an attempt for that. Do not, if you've been given a scientist and you haven't seen him before, don't use any other resources. Treat it as a proper exam. See what you can do from what you've learned already, and we can discuss it in class.